Hi, everyone. So with this presentation, I want to provide an update on the latest news about multi-tenancy for Lustre. So here's the outline for today. First, I'm going to explain what is the node-map feature. Then we will see how it can be used to implement multi-tenancy for Lustre. And then the rest of the presentation will be dedicated to recent or upcoming changes to the node-map feature. Okay, so let's get started. The node-map feature has been here for a while. It's been introduced with Lustre 2.9, which means 2015. And actually, it was even available as a technology preview with 2.7. And initially, the goal was to support a situation where you have different compute clusters that are sharing the same global Lustre file system, and still we want to avoid UID and GID conflicts on the global file system, on the global storage. So how does the node-map feature work? Well, you may be aware that Lustre distinguishes the clients based on their network identifiers. So it's what we call the NID. It's basically the network address of the clients. And then every file system access goes through the node-map identity mapping policy engine. So what does that mean? When a client connects to the servers, so it means when the client mounts Lustre, the servers decide if this client is part of a node-map, which means a policy group made of one or more NID ranges. So this decision on which node-map, which client is part of which node-map, is made only once when the client initially mounts. And so with each node-map, we have a collection of identity mappings. Those identity mappings are simply rules that let you define how the client identifiers are transformed into UIDs and GIDs on server side. Along with these identity mappings, we also have properties that govern access conditions for the clients that belong to the node maps. So basically, here's how you would use node maps. You would use LCTL node map add and then the name of the tenant of the node map to create a node map. And then the first step is to add NID ranges to this node map. So you use LCTL node map add range, -- name, the name of the tenant, and -- range, the NID range that you want to add to this node map. So you can add as many NID ranges as you like. You have two constraints. Those NID ranges must not overlap. And globally for your Lustre file system, one NID can only be part of one node map. Then once you have defined these NID ranges, you can define the identity mapping rules. So it's LCTL node map add ID map, -- name, the name of the node map, -- ID type, so you have to specify if you want to define a rule for UID, GID, or project ID. And then -- ID map, and the syntax is client ID colon file system ID. So for instance, here it's going to map UID 530 on client side to UID 11,000 on Lustre server side. And so you have to repeat this command for all the different ID types that you want to have, and for all the IDs that you want to map. All those commands have to be run on the MGS side. This is the central point to define, to configure the node map entries. So I said there are also a number of properties on each node map. You have two properties that govern privileged access. So you have admin. When this property is set to 1, it means that root on the client remains root on server side. And you have the trusted property, and when it is set to 1, it means that we do not touch to the to the client IDs. We keep them as is when files are stored on disk. And if you have both admin and trusted properties set to 1, you have what we call a privileged node-map, which can be used for instance, administrative clients. Then you have two properties to decide what to do with unmapped IDs. So basically, you have two options. You can decide to squash those IDs, and you have properties to decide to which ID this is going to be squashed. Or you can simply decide to deny access to these unknown IDs. And so in this case, you use deny unknown, and you set it to 1. And it will deny access every time this ID tries to access the files on Lustre. You also have the map mode property. So it's very interesting, this property, because with that you can decide to only map some kinds of IDs and not the others. So for instance, you can decide to only map the GIDs and keep the UIDs and project IDs as they are. So here, in this second example, I'm creating another node map that I call Trusted Systems. I add with node map add range all the, this time, the server needs. And then I set admin and trusted properties to, I set those properties to 1. So it's LCTL node map modify -- name, the name of the node map, -- property, the name of the property, and -- value, the value that you want to use. So here, this trusted systems node map is taking care of all the list of servers, and it puts them into a privileged node map. And when you are using node maps, it is mandatory to have such a node map for the servers. Otherwise, Lustre would not work properly. So it's very important to have that node map of privileged node map for servers. So what happens if you are accessing Lustre from a client that does not belong to any node map that has been created? So there is the default node map. It's a special node map. It cannot be removed. And it's a fallback node map to match all the needs that are not explicitly declared as part of another node map. This node map is special. It only contains a subset of the other regular node map properties. And for instance, you cannot define identity mappings on the default node map. So the way I like to present this default node map is a fail-safe. And I think it's a good idea to make it very restrictive, so that if you have unknown clients that connect to your Lustre servers, well, basically they would end up in this default node map that is restrictive, and so they would not have any privileged access on the cluster. Okay, so once you have defined all your node maps, you can activate the feature. So it's a global action. It's LCTL node map activate 1. And so it means that all the node map definitions will be propagated from the MGS to the other servers, so MDS and OSS servers. And it can take a few tenths of seconds to propagate to the different servers, depending on the load on the file system. So now, how can we use the node map feature to implement multi-tenancy for Lustre? And maybe the first question to ask is, what do we call multi-tenancy here? So to give you a rough idea, you can consider this situation where we want to support different populations of users on the same file system. and provide them with their own storage space. The first idea would be to make as many file systems as you have tenants, but that would not be very efficient resource-wise to do so. So instead, we could try to make just one global Lustre file system and have all those populations isolated inside the same file system. So this is the isolation idea that on which multi-tenancy relies. You can make it possible by making sure you restrict your different populations to only the subdirectory on the Lustre file system that they're supposed to see. So it means we need to be able to support subdirectory mount, but it has to be automatic so that we really restrict the clients to their subdirectories. We also need to carry out ID mapping to avoid ID conflicts. And we also need to find a way to trust the client needs. So if we can trust the client needs, the only thing you have to do is to define a file set on the node map. So it's LCTL node map set file set, -- name, the name of the node map, and -- file set, the subdirectory to which you want this tenant to be restricted. It means that when the Lustre clients mount Lustre, they do not explicitly ask for this subdirectory. Actually, it's somehow hidden, and they just mount Lustre, and automatically the Lustre servers would provide them with this subdirectory. We are also able to make this mount, to force this mount read-only, thanks to the read-only mount property on the node map. So depending on the needs, it can be useful. So now the question is, how can we trust the client needs? Well, it's really up to the situation and how you want to address that. If users cannot be root on the client nodes, it means that they would not be able to modify the Lustre configuration. Otherwise, you can think of different ways to prevent tenant impersonation. For instance, you could use strong authentication like Kerberos or shared secret key. So of course, if you enforce strong authentication, it doesn't mean that malicious users would not be able to try to tamper with the Lustre configuration and try to impersonate another tenant. But if they do so, it means that when they connect to the Lustre servers, there will be a mismatch between the authentication that was used from the client and the tenant information that was stored as part of the node map on the Lustre server side. And so in this case, the servers will detect this mismatch and they will refuse connection to the client. Alternatively, you can think of network level security measures such as VLANs or IB partition keys. Once again, it would not prevent any malicious user from trying to modify the Lustre configuration, but if they do so, well, basically, those modified clients would not be able to reach, to connect to the servers because those connections would be blocked directly at the network level. So that's another possibility to make sure that, the clients are using the needs they are supposed to. So really, the node map feature is the foundation for Lustre Multi-Tenancy implementation. And we have been adding or enhancing the node map feature with new properties to better support multi-tenancy. For instance, we introduced the role-based admin control property, so RBAC for short. And it's a collection of roles that you can give or withdraw from your clients that are part of the given node map. So I'm not going to list all the properties, but you can choose to have all of them or only some of them. For instance, you have the file perms role that would let you modify file owner or file permissions. And so if you do not have this property, it would not be possible to modify those on the files. What else? Very recently, we added the local admin property. And so it's interesting because when you have root on your Lustre client, it usually has some Linux capabilities. But if root gets mapped on server side, you would lose those Linux capabilities unless this property is set. And in this case, you keep the Linux capabilities while you are on server side. So it's very convenient for local administrators of the tenant. Another feature we recently added is the ability to declare ID map ranges. So instead of having to declare your identity mappings one by one, you can use, so it's -- ID map, and then instead of a single mapping, you can define a range. So for instance, here it's going to map all IDs between 500 and 510 on client side to 10,000 to 10,010 on server side. And it also works when you want to remove identity mappings. So you can see that as an admin convenience instead of running every single node map add ID map command. You can use this shortcut. But there's still a problem because internally we are creating as many identity mapping entries as the number of IDs in your range. So it means that if you have a range of a large of 1 million, for instance, you would have 1 million entries in your identity mapping, so it can be slow to process. And maybe more importantly, in some situations, for instance, with service cloud providers, it might be that the Lustre administrators, the storage administrators, are not the tenant admins. And so the Lustre admins are not aware of, and don't want to mess with identity mappings. It's the tenant admin's duty. But still, we need to make sure that there are no identity conflicts when files are stored on disk. So we came up with this idea to apply an offset on IDs. And so basically, for every ID on client side, we store the file with ID plus offset on server side. So in this case, you do not have, you just have one offset rule, and you do not have any individual identity mappings. So there's a new command. It's lctl node map add offset -- name the name of the node map -- offset the offset you want to apply, and -- limit for the number of IDs that you want to offset. So in this example, it means that all IDs between 0 and 69,999 will be mapped on server side to 10,000 to 10,69,999. And so when admins declare those node map offsets, we make sure that those offsets do not overlap. And this is how we guarantee that there will be no ID conflicts on server side. So we realized that with the introduction of this offset concept, it might be a little bit difficult to understand how IDs are actually mapped when they go through the node map policy engine. So for instance, here, let's consider first that we are dealing with a non-root ID. So it's the right-hand side of the diagram. So the first step is to have a look and see if mapping is enabled for this ID type. If it's not allowed, then we just offset the ID and exit. If mapping is enabled, then we have a look at the trusted property. If it's 1, then we just offset and exit. If it's not, then we have a look and see if there are explicit mappings that are defined. So if there is one, we map. If there is no explicit mapping, then we squash. And we end up, once again, offsetting this ID. For root, it's much more easy. So if admin is set to 1, then we just offset the root ID, 0. And if admin is not set, then we look if there is an explicit mapping. We map or squash, and then we offset. So really, the takeaway here is that we always end up applying the offset. So there's no way an ID can escape the offsetting mechanism with this new feature. Okay, so quick words about upcoming enhancements to the node map feature. Once again, in order to increase our capability to support multi-tenancy configurations. So we have seen situations where, there is a need to create node maps at a very frequent rate, for instance, for just the duration of a job, to include just the nodes that are part of the running job. And so in this case, it means that we are going to modify the node map configuration very frequently. And we have this propagation time from the MGS to the other nodes, and it can be a problem in this case. So the idea with dynamic node maps is to create node maps in memory only, and it means not on the MGS, but directly on OSS and NDS side. You could see the dynamic node maps as a way to refine a more global behavior that is enforced by a regular node map. And dynamic node maps are hierarchical. It means they have a parent node map, so it can be a regular node map, it can be the default node map, it can even be another dynamic node map. And the needs that are attached, that are assigned to this dynamic node map, have to be included into the parents. In this case, the dynamic node map inherits all the properties from the parent node map, including the identity mappings. And then you can decide to modify the properties of the dynamic node map. Presumably only lowering the privileges unless the parent grants the permission to raise privileges. So it's just the same node map add command, but with a -d option to say it's dynamic and -p to specify the parent node map. So here, the dynamic node map inherits all the properties from the parent, and then you can use LCTL node map modify to change the properties that you would like to have applied only on the child node map. Another interesting feature that is upcoming in the node map area is called multiple file sets. So as I explained earlier, once you have defined a file set on a node map, it means that all the clients are restricted to this subdirectory automatically when they mount. But this can be too limiting, and in some situations, you would want to be able to provide your clients with several subdirectory mounts. So we introduced this possibility to define several file sets. So there is still the primary file set, which is considered the default. And then you can define alternate file sets. So basically, you would build a list of authorized subdirectory mounts. And as a bonus, we would like to be able to force read-only mount on only the file sets that we want. So there is the new command LCTL node map file set add -- node map, the name of the node map, -- file set, so the file set. So if you just use this command, it will define a primary file set. And you can use the -- alt flag, and in this case, it will define an alternate file set. And if you use, there's a typo here, it's -- ro, then it will force read-only on this node map. So what happens when the client mounts Lustre? If the client does not specify anything, then it will be provided with the primary file set. And in order to get access to the alternate file sets, the client just, puts that on the mount command, just like a regular subdirectory mount. And because here the data source directory is part of the alternate file sets, it's allowed to mount this subdirectory. And because we use the -- ro option, it's forced to mount this subdirectory read-only. So as a conclusion, I hope you enjoyed this quick tutorial on the node map feature. As you can see, it's very convenient to implement multi-tenancy for Lustre, and we're going to keep on enhancing the node map feature so that we can support more and more multi-tenancy scenarios. And that's all I have. Thank you.
Very much. Do we have any questions for Sebastien?
What is the bug history of this node map related code in Lustre? I mean, if we have several laboratories which are sharing the Lustre and each produces some sensitive data, can we trust the software itself?
So, if I understand the question correctly, it's about how we can trust the client needs. Is that correct?
Actually, all of the node map related software in Lustre. Do you recommend it as a isolation for sensitive data?
I mean, so in this model, we are trying to implement, we are implementing a mechanism that controls how clients connect to the servers, and I mean what they are allowed to see. And so the strength of the node map feature is that its configuration is done only on server side, which is considered a trusted, island compared to the clients that are not controlled by the Lustre administrators. And the node map configuration is never exported to the clients. When the client connects to the servers, they are never aware that they are part of any node map. So it's completely transparent, and it's hiding how their connection is controlled by the servers. So this is how we consider it's a secured way to isolate clients.
Do we have any other questions right now? If not, let's thank our speaker. Thank you very much.